What's up guys, it's Rob from BreVITy, and in this video we're going to solve the container with most water problem on LeetCode. So let's get started. Welcome to the grand finale of week 3. Congratulations on making it this far. Remember, step by step, a mountain is conquered. If you haven't checked out the introduction video to this topic by Shyam Suresh, go check it out. Link will appear over here. He explains it in great detail with a pictorial representation, and it'll be really useful to understand the problem. I'll wait. Okay, are you back? Let's continue. So let me briefly go over the problem statement. Basically, they will give us a bunch of lines with various heights. Our task is to figure out the maximum area of the rectangle that can be formed by using these lines. Now from our school days, we will know that the area of a rectangle is the length multiplied by the breadth. Now that we have understood the problem statement, let me briefly go through the algorithm that we will be using to solve this problem. So we'll be using two pointers, start and end. Now start is going to, as usual, point at the 0th index of the array, and end is going to point at the last index of the array. And outside of the while loop, we'll be declaring a flag variable which will be storing the maximum area that we have encountered so far. Now inside the while loop, we are going to check the current length and the current breadth. Now, the breadth is going to be nothing but the end minus start. So in this case, let's say that start is at 1 and end is at 1, 2, 3, 4, 5, 6, 7, 8. So in order to find the width, all you have to do is 8 minus 1, which is nothing but end minus start. So we have found the current width of the rectangle to be 7. Now how do we find the height of the rectangle? We can see that the two poles which we have chosen is of 8 centimeters and 7 centimeters respectively. So we are going to take whatever is the minimum of these two poles. In this case it's 7. So now we have found both the height and the width. Now we are going to multiply it. So we found the height to be 7 and the width to be 7 as well. 7 times 7 is 49. So now if 49 is greater than the area which we have encountered so far, which we are storing in max variable, in the max area variable, what we'll do is replace that with 49, and we're gonna keep doing this. Okay, so the next step is to either increment start or to decrement end. Now how will we know when to increment start or to decrement end? Well, what we're gonna check is which of these two poles are better. Alright, and by better I mean which is taller. Now if the left pole which you have selected over here is taller than the right pole, then we can conclude that the left pole is the better one. So we are not going to try to improve on something which is already better. We are going to try to improve something which is worse. So in this case, since the right pole is worse, we are going to decrement end to n minus 1. So we are going to decrement it by 1. Okay? And then we are going to repeat the same process. On the other hand, if we found that the start pole was lesser than the end pole, then we are going to increment start. And we're going to again find the area of the rectangle and check if it's better than what you have encountered previously. And we're going to keep doing this until the condition start less than end returns false. And that is the crux of this algorithm. In the end, we'll return the max area variable, and that will be our answer. So now that we have understood the algorithm, let us code it in LeetCode. Step 1. Implement the algorithm. Now the first thing we're going to do is initialize the variables. So we know that int start is going to point to 0, int end is going to point to height dot length minus 1, and we're going to have a flag variable max area to store the maximum area that we have encountered so far. I'm going to initialize it to 0. Now we'll open the while loop, and the condition is going to be while start is less than end, as discussed earlier. First we're going to take the width of the current rectangle. So width is going to be nothing but the current end minus the current start. And the length is going to be nothing but the minimum value of the two poles. So in Java we have something called math.min, and inside let's say that I put two variables a and b, it's going to store the value of whatever is smaller between A and B in whatever I'm going to declare on the left hand side. So in this case, if A is lesser than B, then length is going to have a value of A. So inside this, we're going to keep the two heights. So it's going to be height of start and height of end, right? So now we have declared both width and length. Then the next thing is to get the area. So int current area is going to be nothing but the width multiplied by the height, which is length in this case. So if the current area is greater than the max area, what are we going to do? We're going to say max area equal to current area. Easy, right? Okay. So now we have to know when to increment start and when to increment end. So as discussed earlier, if height of start is less than height of end, in this case, what we are going to do is we are going to increment start. Else, we are going to decrement end. And outside the while loop, we can return our current, we are going to return our max area, which is going to be the final answer which will be stored. Once all the iterations of the while loop are complete, whatever the maximum area is going to be stored in max area. So let's run the code and check for any compilation errors. Okay, so the sample test case has passed. So now let's move on to step 2, which is testing for edge cases. Now the first edge case you might think of is what if the given input array has no values? Well, if we look at the constraints given for the problem, we can see that the minimum value of heights in the array is always going to be 2. So we don't really need to worry about that condition. So we can safely assume that all edge cases are already taken care of by our problem and we don't need to implement anything specifically. Step 3, debugging. Now, if I had encountered some problem or bug over here, this is the part where I would be trying to solve it. But since I already know what I'm doing, I did not encounter any bugs over here. So we can skip this step and move on to step 4, which is optimization. Now, we can optimize this problem in a really good way. What we can do is all of these lines over here can be replaced by a single statement. Now, how do I do that? Similar to the math.min function, Java also has something called math.max. So what I'm going to say is max area is equal to math.max of the current max area and the new current area. So what is current area? It's nothing but width into length. What is width? N minus start. So I'm going to say n minus start into the current length, which is nothing but, as discussed over here, math.min of this part. So I'm going to just copy it and paste it over here. And now I can comment out all of these lines of code and it should still work. Okay. And now we can also remove these braces, since if it's a single statement, we don't really need to include braces. And yeah. So now we have optimized the code and we have reduced so many LOC. So now I can literally remove all of this and still submit it and we should still get the same answer. Yes. And we can see that we got a runtime of 2 milliseconds and a memory usage of 40.3 MB. Step 5. Time and space complexity. Now the time complexity of this solution is going to be O of n, where n is the length of the given input array. The space complexity of this solution is going to be O of 1. This is because we are only declaring 3 variables over here which will occupy constant space in memory. Thus, the space complexity is going to be O of 1. And that's it for this video. Thank you so much for watching. If you liked the video, do like, comment and share the video with your friends. Also, if you haven't subscribed yet, do hit that subscribe button to be notified of any new updates. And on that note, this was Rob. You're watching BreVITy. Thank you and goodbye.